As you know, the land sector is the focus of our big new campaign. I'm sure many of you have engaged with it. We have both a terrible legacy and a huge opportunity on the land sector. We are one of the world's deforestation hotspots, which is just outrageous. We're the only developed country in that group. And we clear 680 mcgs of bush a day. Like, we are so bad. And we also log 70,000 hectares of native forest every year, which is, both incredibly marginal, particularly in a time of climate change and driving extinctions. But we also have this huge positive opportunity around our land sector, around embracing carbon, embracing the opportunity for a decarbonised world, about the markets that will bring, about changing the way we do agriculture, about being world leaders. We've got a lot of land, we've got a lot of capacity to actually help the world decarbonise. So I want to hand over to Kobad. He's going to talk to us, as Lou said, for a bit, and then we'll have an opportunity to ask questions. So put your questions in the chat and we'll go from there. So welcome, Kobad, and over to you.
Thank you very much, Felicity and Louise, for having me and that very kind introduction. I'm very flattered to hear from inside sources that the work we've been doing over nearly 2 decades has been really influential and helped to shape what governments in Australia can do, and certainly we've aimed to do that for corporates around the world and governments around the world too. So greetings to everybody from Gadigal country, where I stand at the moment, and very pleased to talk you through some of the work we're doing on sustainable agriculture and our thesis for how the sector can change and evolve. Firstly, just a brief introduction into who we are, where I work, and whose analysis I'm speaking about today. So Bloomberg NEF, we're a division of Bloomberg, the world's largest financial information and media company. We're a division that is an independent research house that focus on the future of energy, the climate system, and the transition to a cleaner economy. And in the last couple of years, we've turned our attention to building, well, I've turned my attention to building up a land and agriculture practice for the company, because that really is the new frontier in the energy transition and opens up also the economy's interactions with nature more broadly, and the work that needs to be done to ensure that we're living both within a climate constraint and our broader nature constraint, which I'll talk about much more. So this is a picture which will come to mind for many of you when we think and we talk about agriculture. This is industrial agriculture, and indeed this is a picture of industrial agriculture in Western Australia, where we have broadacre, very large cropping of wheat and other crops. And industrial agriculture really has been one of the miracles of the 20th century. In the 1950s, the world sort of teetered on the brink of hunger and famine for an exploding global population. And it was the Green Revolution which brought the application of industrial engineering and science and machinery and chemistry to the agricultural sector in a way that enabled us to massively increase production, particularly in the developing world, to feed booming populations there and make sure that there was enough food to go around. So the Green Revolution, which occurred, some 70 years ago, really was one of the most important technological changes which we have experienced as humanity. And it won its founder, Norman Borlaug, the Nobel Peace Prize, as well as many other accolades, and his counterparts in India and Mexico, in Brazil, all instrumental at ensuring that billions more inhabitants of Earth were fed and nourished. But this version of industrial agriculture that still dominates the world today has now run up against some very significant problems. The first is, of course, greenhouse gas emissions. And the agricultural sector globally is responsible for about 23% of global greenhouse gas emissions. And that comes from two major sources. The first are the direct emissions which come from operation of the farm, running of machinery, excuse me, burps and belches from livestock, from the application of fertilizers, etc. So everything that happens on the farm. But then the second major component of that is often not directly attributed to agriculture, although it should, and that is land use and land use change. And that is really all about land clearing and vegetation management on the farm. And that is predominantly driven by the agricultural sector. And so in aggregate, around 23% of direct emissions come from agriculture. Other research shows that in total, if you look at all of the emissions that come from the food system more broadly, that includes refrigeration of food, cold storage, logistics, then the waste handling at the end of food, then it's responsible for about 34% of all emissions. So food is a huge part of the greenhouse gas emissions challenge. The other, less recognized problem is that the agricultural system is the chief driver of biodiversity loss. And scientific estimates suggest that it is responsible for about 80% of the loss of biodiversity that we are experiencing. And the biodiversity crisis is an existential crisis for humanity. Biodiversity and nature's biological diversity underpins life on Earth, and it is declining at rates that are unprecedented in human history. Indeed, we are heading towards the next great extinction, with the last being the asteroid which wiped out the dinosaurs. And the statistics on biodiversity loss are really truly eye-watering. And our dependencies on biological diversity and the services that it and nature more broadly provide for us are really, really significant and should cause us all a great deal of concern. So estimates suggest that about half of all global economic output is moderately to highly dependent on nature, and in ways in which many of us don't often think about. For instance, 99% of the calories that we consume come from the soil, and a third of that topsoil in the world is already in a degraded condition, so that agricultural productivity has been dropping. 70% of cancer drugs and 60% of drugs and pharmaceuticals more broadly are inspired or derived from nature's genetic library and material. And 75% of the crops that we eat rely on insects and animals to pollinate them. These are just some of the examples in which we are intricately dependent and intertwined with nature. And some of the direct economic dependencies, along with that half of total GDP, suggest that if we continue along the path that we currently are on of ecosystems collapsing around the world, then we are looking at wiping out about 2.3% of global GDP, or about $2.7 trillion worth of output by the year 2030. And of course, that dispersion of loss will be uneven, with the poorest countries and the poorest communities feeling that burden the most. And these are just conservative estimates of ecosystem collapse. So taken together, the current impacts that the agricultural system is having on the planet reveal that agriculture is actually the single largest driver of threats to the stability of our Earth's system. That is the conclusion of planetary boundary science, which describes the 9 physical, biological, and chemical processes which keep the Earth as a whole in the Goldilocks state, which it has existed for the last several 10,000s of years, which have been conducive to life. Earth has not always existed in this beautiful equilibrium, and hence has not been so conducive to civilization like we have today. And these biological, chemical, and physical processes have boundaries, beyond which we risk tipping the Earth into a different state, into a hothouse Earth. And these boundaries and these tipping points are mostly irreversible. Now, we are currently breaching, by the best estimates of science, about 5 of these planetary boundaries. The agricultural system is driving the majority of those transgressions, as you can see by the dotted areas here. And so it eclipses even our fossil fuel dependent energy system as the single largest driver of threats to our children inhabiting a stable planet. Why does the ag system have such an outsized and enormous impact? Well, there are really 4 key chief drivers. The first is the sheer scale of land and sea use. So currently 50% of all ice-free land on Earth is used for agriculture, and 55% of the oceans are industrially fished. Even greater percentages of the Earth, up to 75% of the habitable surface of the Earth, has been disturbed by humans. And a large component of that additional to the 50% is from agricultural land that is no longer in productive use because it has become degraded. That's the global statistic. And for Australia, about 60% of our land mass is currently used for agriculture and forestry being a small 2%. You can see that here in this map and this great data which has been compiled by ClimateWorks. And the majority of that land in Australia is used for grazing of livestock. That's true globally too. About 2/3 or even towards 3/4 of all that agricultural land, so about 35% of the surface of the Earth, is used to graze livestock. And these livestock provide us with only about 18% of our calorific intake. So it's a pretty inefficient use of those land resources. And you may think that in Australia, a lot of that livestock grazing land, which is represented by the grey on this chart, is sort of, marginal land, native pasture, which you can't really do anything else on, and maybe doesn't house all that much natural value or biodiversity. Well, actually, what the numbers on this chart are showing are the 19 ecosystems in Australia which are currently in a state of collapse. And many of those ecosystems are in these areas of native pasture, which you wouldn't regard as being, lush, forests or the typical sort of views of what rich biodiversity is. But nevertheless, they are critical ecosystems with endemic, that is unique species which exist nowhere else on the planet. Now, as Felicity mentioned in her introduction, land clearing and deforestation continues to be a major problem in Australia, and we are somewhat unique in the developed world on this front. And this chart from the State of the Environment report shows that much of this land clearing is impacting threatened species and threatened ecological communities. And the majority of that land clearing is actually non-compliant. So it's essentially not permitted or illegal, and so not being adequately enforced. The majority of that is occurring in Queensland. Next is New South Wales. And once again, you can see that a lot of that land clearing is happening on frontier areas of land in the interiors of Australia, where there are many of these threatened communities and species. The second major driver behind agriculture's outsized impact is water use. So 70 to 84% of all freshwater withdrawals globally are for agriculture. So that's water drawn from rivers, from lakes, from dams, from aquifers. And we all, of course, in Australia know that water stress is an acute problem, which is driving many of our ecosystems to dysfunction. And this is true around the world. Now, the best estimates of scientists are currently that we're probably going to run out of freshwater supplies by somewhere between the year 2030 and the year 2040 globally. And many parts of the world are already acutely water stressed. Fertilizer over application is the third major driver. Right now, human activity and agriculture is adding more nitrogen to the soil than all of nature's natural processes. And only around half of those applied synthetic nutrients are actually absorbed by their target crop. the rest of those nutrients end up leaching into the environment, often into waterways, which is driving algal blooms or what's called eutrophication, which basically depletes those water-based ecosystems of oxygen and makes it impossible for anything to live there. These algal blooms are a massive problem in rich marine ecosystems around the world, covering very large areas of sea surface. That over-application of fertilizers is also degrading soils, because when you load too much fertilizer into the soil, it kills the microbes which are responsible for our natural nutrient cycles and processes. So you end up in a catch-22. You need to fertilize more to compensate the fact that the natural processes aren't working. That kills them even more, and then you end up with all this degraded land. The fourth major driver is pesticide poisoning. So currently, 98% of sprayed insecticides and 95% of herbicides are reaching a destination other than their target species, or other than the pest. Now, what happens to all these toxic chemicals then is that they are killing other species, and they are also bioaccumulating in ecosystems and in the food chain. So some examples of that are that currently about 40% of insect species in the world are threatened with extinction. And as I outlined before, we depend on these insects to pollinate our crops, and loss of pollinators is already a huge problem for many agricultural regions around the world. And bioaccumulation means animals eat those insects, and then bigger animals eat those other animals, and so these toxins end up staying in these bloodstreams, and they accumulate all the way up to us. And of course, they end up killing those larger mammals and animals too. A recent survey found that glyphosate traces were present in something like 60 to 80% of the US human population. So these chemicals really, they make their way all the way up to us. Now, at the same time that the ag system is driving and facing these huge environmental crises, we indeed are faced with a growing population. Now, the best estimates of projectors and economists are that we're heading to a global population of between 9 and 10 billion by the year 2050. And not only is the population growing, but of course it is becoming more affluent. And we know that as people become more affluent, they tend to consume a little bit more food, but a lot more protein and meats, and those require have a much greater footprint on the earth. So the projections are that we need to be producing probably about 31% more food to feed our growing population. And so the agricultural system is really faced with a trilemma, or a grand challenge, of needing to reduce emissions to net zero by the year 2050, as outlined by the Paris Agreement. It needs to halt and then reverse its impact on nature and its contribution to the biodiversity crisis, a goal of which was set at the UN Convention on Biological Diversity, the Global Biodiversity Framework in Montreal last year, which is the sister agreement to the Paris Climate Framework. And the headline goal there is to protect 30% of land and 30% of sea around the world by the year 2030, up from about only 14% of land today. And there are also a bunch of sub-goals there about reducing pesticide use, reducing the harm from fertilizers, etc. And then, as I mentioned, to feed a growing population. So how can this possibly be done? How can we produce more when we're already having such devastating impact on the natural environment? Well, our research indicates that there are 5 broad solutions that offer us a practical and promising path towards a sustainable agricultural system. The first of these, our first pillar, is the need to produce sustainable proteins and fats, or calories from protein and fats and oils, with a much smaller. These have gained quite a lot of popularity, but have recently faced headwinds on taste and health concerns. But a new generation of alternative proteins is currently under development and being commercialized, And that's called cultured or lab-grown meat, which can produce molecularly identical animal as an animal product. Precision fermentation is the other technique, which is basically just like a brewing process, like we have for beer or for yogurt, which can produce exactly the right proteins to be able to make a milk without cows, or could also make all of the building blocks for a chicken patty or some new food type. Now, these are a really interesting scientific process, which is currently being commercialized and has received regulatory approval in Singapore and the US. We're seeing a lot of venture capital funding flow into these companies. And the impact that these alternative proteins could have is enormous. So the environmental footprint of a kilogram of plant-based meat or cultured meat is drastically lower than animal livestock. And the land footprint is incredibly important because it's really land use which governs and determines and is the best indicator of our overall biodiversity and nature footprint. You can also see here that it has a drastically lower emissions footprint because you don't have animals that are belching, and you also don't have the impact that they have on the land, which also tends to release carbon. Now, if we started to see some portion of our protein needs being met by alternative proteins, then this would substantially reduce pressure on the land system and free up land for other important uses, such as nature restoration, meeting this 30% conservation or protection target. It could also enable us to have more space to grow more crops. Some of those, to feed more people and potentially for production of bioenergy. And there could be other interesting uses for that land too. Now, I'll state that I think there will always be an important place for animal protein and and livestock in our diets. But what this could possibly mean is that alternative proteins help to serve our needs for low cost, everyday consumption of meats like chicken breast or mince meat or fish fingers. The things that we consume on a daily basis that don't cost much, they don't actually bear much resemblance to the original animal because they've gone through some sort of processing or cutting or filleting. And so these are the low-hanging fruit that could be met by alternative protein production, which would mean that animal consumption, our consumption of animal protein would go back to being the special thing that we do on a Sunday, like a Sunday roast. And this would rebalance our protein intake and help to drastically reduce its environmental footprint. The second major pillar is the development and deployment of green agrochemicals. Now, the use of chemicals in agriculture is going to be a necessity. It's what supports our ability to produce enough food to feed the world, and there will always be a need for the use of added nutrients and for pest control. But we need to figure out, and there are ways we can do this with fewer side effects. So producing fertilizers from green hydrogen will help to reduce the emissions impact of fertilizers, which are currently quite substantial. A couple of % of global greenhouse gas emissions just come from producing fertilizers from fossil fuels. But it doesn't address the nitrogen pollution problem, which is a more significant issue for the planetary system. There are other classes of fertilizers which can help to do that. What's called biofertilizers or biostimulants, and similarly biopesticides are basically working with nature's microbial processes to help to add these to the soil and boost their function and their efficiency in the soil, which leads to stronger plants, more resilient to heat stress, more resilient to pests, better able to access the synthetic nutrients that we add to the soil. And these are an exciting and new class of agricultural chemicals, which are already being marketed and deployed by many companies. And there's much more that could be done. There's also a lot of opportunity to just be better at the way we apply them by using better technology. So precision spraying or application, using artificial intelligence to be able to determine when the plant is best able to soak up nutrients, or using machine learning to identify a pest and precisely spray pesticide to the pest rather than to just carpet bomb the entire crop. These are sort of agricultural robots and precision technologies which are also being commercialized and deployed. The next key pillar is sustainable intensification. So that is a class of technologies and improvements in crop science that will enable us to produce more using less land, less water, less fertilizers, less pesticides. And this is really about genetic science. And to some extent, the use of those precision machinery and techniques that I mentioned, and to some smaller extent, the use of controlled environment agriculture. So an example of this is perennial crops. So currently the majority of our calories from wheat, from rice, and corn, come from crops that are just annual. They grow once and then they die. And they've been bred in that way because that was the way we were able to produce these mega productive plants. But the people are working on now developing crops which are perennial, so they could last for 5 harvest cycles, or 3 to 5 harvest cycles, meaning that you need to have less agricultural machines, you need to do less breaking of the soil, which enables greater nutrients. Their roots grow deeper, they can capture more carbon, they therefore become stronger, more resilient to pests, better able to access nutrients, etc. There's been really good success with perennial rice. The Chinese have developed a perennial rice varietal, which has as good output as annual rice, but uses less of all of the inputs. And there's research going on into perennial grains as well. The fourth pillar is carbon smart farming. Now, this is really a description of a bunch of things that we know how to do. So the practices around capturing more carbon in the soil and improving soil carbon and therefore soil health and productivity are pretty well known. There's been lots of documentaries on it. These are things that are practiced widely in many countries and many parts of the ag system and in many farms around Australia. These are things like not tilling the soil, using cover crops, doing intercropping, rotating your crops, doing mixed animal grazing, agroforestry, etc. These are land management practices. The key really is that we need to scale the adoption and mainstream these techniques. And in order to do that, farmers need to get paid because they face a risk in changing their practices. Farmers only usually have 20 or 30 crops in their whole career. And so they face a lot of risk if one of those crops fail. That, cuts out a good percentage of their lifetime income. And so farmers need to really be paid to cover the risk of changing their practices, which they have honed over many decades. In many cases, these also require some new machinery, or they face capital costs. And so farmers need to be incentivized to do that. Now, carbon markets are probably the most effective tool. And farmers in Australia is fairly well developed in this field, in that our carbon market has really focused on originating credits from the land. Not all that much has actually come from the farm itself. It's come mostly from avoided deforestation and some other things, but there's a lot of scope for this to be able to increase. And as carbon prices go higher, that will make much more of this possible, because there's more money to be made, there's more incentive for a farmer, and there's more incentive for all the business people to bring those solutions to the farm and create what's called methodologies and project aggregators to be able to work with farmers to say, hey, if we do this, you can start to earn carbon revenue, as well as improving the sustainability and the long-term productivity of your farm. The fifth pillar is the valuation of biodiversity, which can be created via biodiversity markets and finance. So this is basically a similar journey to what we've been on carbon, which is saying that we need to be able to value biodiversity in our financial decision making, in our system, all the way from government to financiers to farmers to supermarkets to us. Nature provides all these economic services for us, but we overexploit them and we neglect prudent management of nature because we don't pay anything for it and we don't ascribe any financial value. We just sort of regard it as something that happens, something that's free. But it's worth an awful lot. And now there are a whole bunch of different systems and frameworks to enable us to do that. These are currently in development. So there's disclosure and reporting frameworks which will make companies think about what are their impacts on nature and also what are their dependencies. So if you're a large agricultural producer, you now will very soon have to think about all the ways in which you're actually dependent on the land and therefore need to invest in better management of it. You're also dependent on the services that are provided by nature and national parks and nature in an intact and well-functioning state. Even though that may be outside the boundary of your land, you depend on the services that come from those areas of forest. And so there are these tools which are coming through the financial sector, such as the Task Force for Nature-Related Financial Disclosure, which will make companies start thinking about this. And once you think and you start to measure, then you start to manage. And so these things can be really important. We're seeing, of course, things happen at the international level. I mentioned the UN framework. There's things happening at the finance sector. There's target setting initiatives. There's stuff in policy reform in the EU and the US and many other countries, all of which to try and get us to think about and value nature. The last, and certainly not least, is the need for national agriculture and environment policy reform. So today, the world spends, and governments around the world spend about $500 billion on subsidies which are harmful to nature, on agricultural subsidies which are harmful to nature, which encourage unsustainable farming, unsustainable land management practices. And these really need to be reformed and repurposed to redirect them to support sustainable practices. Now, Australia actually is not too bad on this front because we don't have a huge farm subsidy program like the EU does or the US does, which is riddled with perverse incentives. Australia actually, we provide very little subsidy to our farming. It's a really market-based system. But there's ways in which we can provide better incentives to farmers and support for them to be able to change their practices. And this is something really important around the world. So there you have it. Those are the 5 pillars that we think can help us to achieve change in the ag system, to feed 10 billion people with food that they want to consume whilst remaining within our planet's boundaries. So very happy to take some questions now, and hope that you found that interesting and thought-provoking.
I'll answer that.